All right, this is problem 2B.2, alternate procedure for solving flow problems. It says we've used the standard procedure, which is just the shell balance procedure. So that's what this 1, 2, 3, 4 is. And it's asking us to basically derive the equation by using two equations that are already in an example problem. Equation for momentum flux and a Newton's law equation. So those equations are 2.2-10 and 2.2-14. So 2.2-10 right here and 2.2-14. So we basically just insert 2.2-14 into 2.2-10 into this derivative here, and we go from there. So yeah, that's what I did. Here's the equations I wrote out again, and then so the boundary conditions. First boundary condition at x equals 0, tau xz, or the shear stress, equals 0. So this is because tau x equals the derivative of Vx, and since Vx is at a max here, this is a max, the derivative of that will be 0, because at local maxes and local mins, the derivative is always 0. So that's why that boundary condition is at x equals 0, tau x z equals 0. All right, the second boundary condition at x equals sigma vz equals 0, and that's because this length here is sigma, and so at x equals sigma, we're at the wall, and because of law of the wall, the liquid moves at the same speed as the wall when it's at the wall, so vz equals 0 on this surface here. Yeah, so that's the boundary conditions. So now we just plug this equation into here, and we get this, and then we separate and integrate. Do that, and then we can use the first boundary condition because we have this dvz dx, and that's one of our boundary conditions. So this equals 0 when x equals 0. So plugging that in. Yeah. And from that we get C1 equals 0. All right, so now we're isolating the derivative so we can integrate again. Just dividing the u over, or the viscosity and the negative sign over. And we get that on the right here. And separate and integrate again. Obviously, we get the C2. So now you got to use the second boundary condition, which is the velocity is 0 at x equals sigma. So just plug that in. 0 for velocity, and then why is this not showing up? Sigma. Sigma squared for x squared. So then you get C2 equals this expression here. So now you plug in C1 and C2, and C1 into the expression, which is, where's the expression at? Into this expression here. I guess I just took out C1 because it's 0, so I just didn't put that. So yeah, plug in C2. So yeah, that's this expression here. I don't know why the mouse isn't showing up. And so we're just doing some simplification and like combining of like terms to get it into the same form as it shows in the example problem. So we're factoring out this density cosine term, x squared and sigma squared, or negative x squared and sigma squared. So that's sigma squared minus x squared. And then we got to take out the x, or the s, or sigma squared out of the parentheses. So we divide this out, and then we multiply outside by sigma squared. And the reason I'm doing all these operations is just because 2.2-18, this is what I got. Oh, wait, does that make sense? Yeah. Okay, yeah, the sigma squared's right there. Okay, yeah. And I'm just looking at this equation to match it. I'm not like just blindly doing random stuff. I'm just trying to match this equation to this. And yeah, I get it. So that's the video. That's it. Bye bye.